Project MC Squared was a TV program for kids where high school girl spies would save the world using science and technology. And the project had, or the TV show had a merchandise, and one of them was this fabulous pixel purse. And so, the pixel purse, it uses an LED matrix. So I didn't know anything about this until I saw this tweet saying that, you know, they were on sale for $6.16, coming down from the original price of $60. And that's really interesting because if you use the LED panel itself, even on AliExpress, it's usually about $15. So I've always wanted to make one of those really fancy LED cubes. And so you have a 2:1 aspect ratio for these LEDs. So in order to make a cube with those things, you need 12 of those purses. But Amazon had a purchase limitation. You could only buy a few of them. So I recruited my colleagues and organized a group buy. And 3 days later, these boxes arrived at work. And I love to think that there is a very confused data scientist at Amazon trying to figure out why a major graphics company is buying all these purses. But anyway, so if you look at it closer, I mean, it seems like it's fabric, but it's not. It's really a very ugly, hard plastic case. And then that's an aliasing thing, so that's just a picture thing. Anyway, but if you look inside, it's very simple. You have the LED matrix, you have some electronics, you have a switch, and you have 4 AA batteries. So in order to avoid trouble with my wife, because I already have so many boxes in the garage, I did a rapid controlled disassembly. And so basically, there is the loot, 12 panels, 48 AA batteries. I will never have to buy those again. And then a whole bucket full of screws and some electronics, including, I desoldered the components from that, 4 megabit SPI prom and some voltage regulators. Now, I'm not really a fashionista, really, and my hobby is actually field programmable gate arrays, FPGAs. And so these are pretty expensive for hobbyists, especially in low volume. But the way around that is to go on eBay and you find products that actually use FPGAs, and then basically repurpose them for your own use. And so Cisco is one of the companies that really buys a lot of FPGAs. One of the major benefits is that they can use operating system updates to reconfigure the FPGAs with their own, with bug fixes and stuff like that. Now, if you look at the board, it's really, you have an off-the-shelf modem that fits in a PCMCIA slot, and then the FPGA itself is used as glue logic to connect it to this HWIC slot. And that slides into a standard Cisco router. And so you can expand the router that is basically a LAN. You can make it a one, I give it a one connection. So if you look at the component itself, you have the FPGA. Very important, you have a JTAG USB blaster pinout. That's a debug port. Then you have an RS-232 connector, some RAM, some unpopulated NOR flash RAM, etc. It's really very, very useful for hobbyists. So I set out to completely reverse engineer that thing, and this is the high-level block diagram. And now all the low-level details about how to program, you can find it on the web. It's on my GitHub. Okay, now the HWIC connector that Cisco uses is proprietary, and so what you need, I designed a small little PCB that converts this HWIC pinout into a standard 2.54 millimeter pin header, such that as a hobbyist you can use that and you don't need to mess with these really tiny pins. And then if we talk about PCBs, you know, when I was a kid a long time ago, making your own PCBs was really a very nasty procedure. You had to use all these kind of really dirty chemicals. You had to shine with UV light an image onto a copper plate, and you had to use other nasty chemicals to etch that away. And if you were really lucky and experienced, eventually you might end up with something that actually looks nice. And so I never got to it. But if you go look at this today, you can, I decided that finally it was time to make my own PCB, and today these Chinese companies offer prototypes for really cheap. And so I downloaded one night KiCad, and that same night, it was very late, I was able to upload a design to JLC PCB, which is the company I used. And 3 weeks later, a very nice PCB came out in the mail. And the amazing part is, it's $2 for 5 PCBs, which is just astonishing, I think. And then there's another $5 to ship it from China to here. So for $7, you end up with a professional, very high quality PCB. And PCBs are an example of mass volume, low cost, and really high precision mechanics if you think about it. You can have the vias, they're like 0.2 millimeter in diameter. So think about what kind of precision you have there. And that made me think, well, you can not only use PCBs just for electronics, but what if you use it for pure mechanical stuff? I mean, I don't know how to use a 3D printer. I don't have a laser cutter. But maybe you can use PCBs to do mechanical stuff, and it has nothing to do with electronics. And as a proof of concept, I decided to design a badge for Bang Bang Con. And same thing, I installed Inkscape, uploaded the bitmap, converted to an SVG file, and then I used a plugin called SVG to Shenzhen that converts the badge into a PCB and then just produced it. And then this is the the badge. And then I gave that proof of concept to Josh, who really took it to the next level, and that's basically the badge you have around your neck. But yeah. But it really, if there's one takeaway of this talk, I think is PCBs are so cheap and so easy to make, and you can use them for more things than just electronics. I mean, there's all kinds of possibilities I can't even think about. Anyway, so now we have everything in place for the cube. We have cheap electronics with LED matrix panels. We have a potential way for mechanics, so let's build something. And so LED panels, they have this weird construction and a very weird interface called the Hub 75. If you want to have like color shades and whatever, you need pretty precise timing to control every LEDs in some kind of serial format. And FPGAs are really perfect for that. So I designed on FPGA a driver to do that. And then I added also a soft RISC-V CPU on there, which then basically provides the pixels so that you can get your image. And this is the hello world of LED panels. And then you can see there the FPGA driving that's a custom board at that point, and a prototype. So then comes for the mechanics. So I decided on a pyramid structure that was built out of 3 identical legs. And with a caliper, I had to be really precise in order to find exactly on the LED matrix panel where the holes are. Then you put those holes there, and I used these kind of right angle connector things to basically solder them all together. And then basically that's the result from that. So here you have those things, and this will form the structure that keeps everything in place. And then it's time to assemble. So you start with 2 things, and you see everything around it, and then you just build it up. And to me, this really gave like the feeling of the Death Star tunnel in Star Wars. I think it looks really cool. Now, I only show you this once, this whole sequence. In reality, I did it about 4 or 5 times, and there's 60 screws in there. It takes hours to really get this right. And just to give you an example about why I had to do this, it's just to fix mistakes, right? And here's a good example. Here you see some of the LEDs, and in the middle you see that screw, right? And it looks fine. But when you zoom in, you see the problem. If you really tighten this, then you will get a short circuit between those 2 things. And again, there's 60 of these screws like that. So the solution was to basically use this 5-second UV hardening glue, and for each screw, put a little blob of glue on there and harden it, and now you have an insulation layer between the screw head and the thing, and basically you don't have issues anymore. And then this is basically the end result. You get something that looks really nice. You can get more information about it here. So I have a bunch of articles about it. You can look it up online. And well, now let's see if we can get this to work. Oops. Okay. All right. And here it is. Yeah. And that's it. Thanks.